I'm going to leave a couple lines up here first. Well, a few more than a couple. Nothing crazy, but I'm going to write some stuff up there. But before I get there, I'm going to introduce what the questions are going to look like today. Today you're going to see questions that will ask you how many and what type of roots does the following have? And then I'll give you something like this. So, to break this down, we should look into a couple things. Like, first off, what are roots? What's another name for roots? Nope. 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 Not square. I missed what someone else said. X-intercepts. Roots, x-intercepts. Zeros. What's the last one? Starts with an S. Solutions. Roots of a quadratic equation are just another way of saying solutions. So it wants to know how many and what type of solution these are. When it says how many, quadratic equations can have how many possible answers? Two or? One or?
Zero.
No real solution, which would result in two imaginaries. And that's the type that it's talking about. It can have two real, two imaginary, or one real. Now, there are a couple of different ways that we can approach a problem like this. Option one, just find the roots and tell me, are they real, are they imaginary, and how many of them there are. But if I only ask how many and what type of roots they are, doesn't that leave a lot of extra work? Maybe, maybe not. So the question is, how could I figure out how many roots and what type they are without having to go through and solve everything? Now, it probably shouldn't be a shock that if this is coming up in the quadratic formula section, it probably has something to do with the quadratic formula. What is the quadratic formula?
Negative b plus minus the square root of b squared minus 4ac over 2a.
Perfect. So, plus and minus means this is how many equations? Two and one. Now, if there's one solution, that means that the two equations the plus version and the minus version would have to give you the exact same answer for there to only be one solution. I could go through and set them equal. You are 100% right. what would guarantee that these two things are equal? Do you notice that this is the same in both equations? Do you notice that this is the same in both equations? So it has to do with this, because that's where the change is. One's adding, one's subtracting. When can you add and subtract the exact same thing and guarantee you get the same result? 0.
0?
You have to add 0. 0 is the only thing that when you add it and you subtract it, you get the same thing. 5 plus 0, 5. 5 minus 0, 5. You could do this with every single number. Adding 0, subtracting 0 would be the same thing, which means this thing right here would have to be equal to 0 in order for us to get one real solution. The square root of what is 0? Which means this b squared minus 4ac would have to be 0.
0?
So, if I want one real solution, b squared minus 4ac has to be 0. Now let's talk about two real solutions. Two real solutions means that when I do this, these two are not equal. Which means that's not 0. But I still want them to be real. What makes solutions imaginary? Negative inside the square root. Wait, you're telling me it has to do with the inside of the square root again?
Yes.
If the inside of the square root, the b squared minus 4ac is negative, that's when I get imaginary solutions?
Mm-hmm.
What if the b squared minus 4ac is positive?
Real.
That's when you get real. This right here brings us to what we're talking about today. Today we're talking about something known as the discriminant. And the discriminant is as follows. It is b squared minus 4ac. It is the stuff underneath the square root in the quadratic formula. Right, Mitchell?
Yeah.
Thank you. And it will tell you the number and type of the zeros, of the roots, of the solutions of the x-intercepts. And as we discussed, if b squared minus 4ac is a positive number, in other words, it's greater than 0, you will have two real solutions. Two real roots, two real zeros, two real x-intercepts. On the other hand, if b squared minus 4ac is equal to 0, that's when we have only one real solution. On the other hand, when b squared minus 4ac is less than 0, in other words, it's negative, you will have two imaginary solutions. Now, just one real quick thing while we are breaking down our quadratic formula. The stuff inside the square root is the discriminant. The stuff not inside the square root, x equal, I don't know why I broke it off there. X equals negative b over 2a should look familiar as well. Where have we seen that before? Has something to do with the graph. When a quadratic equation is in standard form, x equals negative b over 2a is the equation for the axis of symmetry. The axis of symmetry comes out of the quadratic formula as well. The square root of b squared minus 4ac moves us away from that axis of symmetry to find the x-intercepts. Okay, So that means if I come across a problem like this that says how many and what type of roots are there to the following equation, I do not have to do the full quadratic formula. Could I? Sure. Do I need to? No. I can just find the discriminant. To find the discriminant, first thing I need is it to be equal to 0, because I can't do anything regarding quadratic formula without being equal to 0 first. As I do this, I combine like terms, and I should probably rearrange some things. I'll start with the 25x squared, but what should probably come next?
20x squared.
Negative 20x. Not squared.
Yeah.
Plus 4 equals 0. What's A? 25. What's B? Negative 20. What's C? 4. And since I'm just trying to figure out number and type of solutions, I just plug into b squared minus 4ac. And if I write it like this, I have done something wrong. Parentheses need to be around that b squared if it's negative particularly. What do we get?
0.
Can anyone verify we get 0? Yes, and if b squared minus 4ac is equal to 0, how many and what type of roots are there? One real root. Yep, that's what it asked for. Negative x squared minus 2x minus 5 equals 0. If I'm going to do the discriminant to find out the number and type of solutions, what should I start with? Equaling 0. But, done. Next thing I should do is b squared minus 4ac. I recommend identifying your a, identifying your b, and identifying your c. Is that an absolutely required step to write it all out like that? No. Do I find that it tends to save mistakes? Yes. But yeah, it's b squared minus 4ac is what we're doing. Negative 2 in parentheses squared minus 4 times negative 1 times negative 5. Luke got negative 16. Can anyone else verify? If the discriminant is negative 16, what number, or how many and what type of solutions are there?
2 imaginary.
2 imaginary solutions. Or roots, or zeros, or x-intercepts. I don't care which it asks about. Now, sometimes they might ask a follow-up question, or sometimes they may have asked another question altogether. Sometimes they might ask you not only what type and how many, and I'll be honest, this is most of the time they want this as well. They might ask you what the discriminant is. What is the discriminant? Hint, it's a number. It's the negative 16. It's what we got to determine that. Make sure you are not taking the square root of it to figure it out. It's a common mistake. People then square root it. Okay, follow up number 2. What are the roots? Or zeros? Or x-intercepts? Or solutions? If I ask this as a follow-up question, what are you about to do?
The rest of the equation.
The rest of the quadratic formula. But here's the thing. That rest of that quadratic formula, that negative b plus or minus square root b squared minus 4ac all over 2a, haven't I just done part of it already?
Yes.
So, x equals negative, b was negative 2, plus or minus the square root of. Yeah, I can type in b squared minus 4ac, but what is b squared minus 4ac going to get me?
Negative 16.
I could go directly to putting negative 16 right there. All over 2 times a. 2 plus or minus all over negative 2. What is the square root of negative 16?
4i.
It's the square root of negative 1 times the square root of 16, which is I times 4, which is indeed 4i. Remind me, when can I simplify this further? When all 3 whole numbers divide by the same thing. Do they?
Yes.
What number do they divide by?
2.
Negative 2, because generally you don't want to leave the bottom negative. Negative 2 divided by, 2 divided by negative 2 is negative 1. Plus or minus 4 divided by negative 2 is negative 2, but since it's got both plus and minus, I could just do 2i all over 1. Are the ones necessary?
No.
But is the negative 1 necessary?
Yes.
Yes, because it's not being multiplied. It's negative 1 plus or minus 2i. Wait, can't I just do like 3i?
No.
They're not like terms, you can't combine them. Ta-da! That's the rest of the notes.